what will happen if a duplicate request reaches your API, and what are the consequences of processing such a request. You could solve all of this by implementing API idempotency, and I'm going to show you how in today's video. Idempotency in a RESTful API means that if you send the same request to the API multiple times, you're going to get back the same response, and you're only going to trigger some side effect once. So this is an important quality that we are striving for when we are implementing idempotency, and we're going to be adding it to our post endpoint for creating a product. I'm going to start off by defining an idempotent command that the create product command will implement. So in the application folder, I'm going to add a new folder, which I will call idempotency, and inside of it, I want to create a new class that's going to represent my idempotent command. I'm going to make this class public and abstract, and it can actually even be a record, and it's only going to have one thing on it, which is going to represent the request ID for this current command. It's going to implement the iRequest interface from MediatR, and now I'm going to update the create product command to inherit from the idempotent command. So I'm going to add the request ID as part of the create product command constructor so that I can pass it to my idempotent command base class. Now the question becomes, how am I going to provide the value for the request ID when creating the create product command? A good solution is going to be to include the request ID in some sort of custom request header that you're going to be sending to the API. I'm going to add another argument to our endpoint, and it's going to be a string representing the request ID, and it's going to come from a header. So I'm going to add a from header attribute, and the header name is going to be X-Idempotency-Key. When someone is sending a request to my API, they're going to need to include this header, and I'm actually going to enforce that this value is a GUID, otherwise you're going to get back a bad request. So let's do something like this. Let's say if not GUID, try parse, and you're going to try to parse the request ID that we get from this idempotency-key header, and you're going to move it into an out parameter, which I will call parsed request ID. So if you're not able to parse this, then I'm sorry, but you're going to get back a bad request. So I'll say return results bad request. Otherwise, we have our parsed request ID, and let's pass it to the command. The from header attribute is complaining because I forgot to actually set the name property. So now everything should be as expected. The next thing I'm going to add is a pipeline behavior also in the application project. So I'm going to add a behaviors folder. Let's add a new class inside, which I'm going to call IdempotenCommand pipeline behavior. I'm going to make it internal and sealed. It has to be generic. So the first argument is the T request. The second argument is the T response. And it implements the iPipeline behavior interface. I'm going to pass T request and T response as the generic arguments. And the important thing is I'm going to pass in a generic constraint that the T request has to be an idempotent command. So now my pipeline is only going to be running when I'm sending an idempotent command instance, and let's implement this. Inside of the pipeline, I want to check if a request with the given ID already exists, then I break the pipeline, otherwise I process the command as normal. Let's add one more abstraction inside of the idempotency folder, which I will call IdempotencyService. This interface is going to have two methods. One is going to be a method returning a Boolean value, which I will call request exists async, and is going to have one argument, which is the request ID. The second method is also going to be asynchronous, and I'm going to call it create request async. This is going to be the method responsible for storing that this request has just occurred. Besides the request ID, I'm also going to give it the name of the request that was just processed. So if I head back to my IdempotentCommand pipeline behavior, I'm going to inject this IdempotencyService from the constructor, and inside of my handle method, which I will make asynchronous, I can say this. So if await IdempotencyService request exists for this request ID, then I need to return. What should I return in this case? Well, let's say I return whatever is the default response for the T response type. Now, because my commands don't return a value, this is going to be just void. But if you are returning values from your commands, then you need to consider what the default value should be. If my precondition passes and the request does not exist, then I'm going to go ahead and create it right away. So I'm going to call IdempotencyService create request async, and I'm going to pass it the request ID, and I'll grab the name of the T request argument, which is going to be the name of my command. So I'm going to pass these to the create request method and create this in the database. After this executes successfully, I'll go ahead and run my command by saying await next, and then I can return the response from my command. The reason I'm creating a request before processing my command is that both of these operations could potentially fail. I would much rather have my entire request fail because the command couldn't be processed, rather than something like this, where I, let's say, successfully process the command, but creating the request fails, and then I would have to retry my command where the command actually succeeded in the first place, and it was the IdempotencyService that caused the error. With this setup in place, let's register our pipeline behavior in the dependency injection class. In the call to add mediator, I'm going to register our pipeline behavior by calling add open behavior. Then I say type of and specify my pipeline behavior type. So now I can focus on implementing the IdempotencyService, and I'll head over into the persistence project. So let's create an idempotency folder, because I'll need to do more than just implement this service. So I'll create a class which will hold my IdempotencyService, and let's make it internal and sealed, and we need to implement the IdempotencyService interface. I'm going to need a table in the database that's going to persist my requests, and I'll also need an entity to represent this table. So I'm going to call it IdempotenTRequest. It only needs to have a few properties. So I'm going to say public GUID ID, which is going to be our actual request ID that we sent to the API. Then I'm going to give it a name, which is going to be the command name. And let's include a date and time when it was created. And I'm going to make it in the UTC time zone. There should be enough information for my idempotent request. Let's add an entity configuration. So idempotent request configuration, and I'll make this internal and sealed. We need to implement the iEntity type configuration interface and specify the idempotent request as the generic argument. So now I'm going to quickly configure this entity. I'm going to say that the key is the idempotent request ID. Then for the name of this idempotent request, I'm going to say that it is a required property, and for the date and time is going to be required by default. Let's also configure the table name. So I'm going to say to table, and I will call it idempotent requests. All right. Now all I need to do is to generate an EF core migration and execute it to create this table in the database. So I'm going to omit this step because I don't think it's necessary, and let's head over into the IdempotencyService. So I'm going to inject the application DB context, and we're going to use it to implement our methods. So in the request exists async method, we're going to say return context, and I'll say set and access the idempotent request database set. And let's call the anyAsync method to check if there is a request with this given ID. Of course, I need to await this to return a Boolean value, but this should satisfy our request. And then in the create method, let's also make it asynchronous. Let's create our idempotent request entity. I'm going to say new idempotent request. Let's set the ID to the request ID and the name to the name that we get from the route. And for the date and time, I can say date time UTC now. Now I need to add this to my database set. I can just say context add and pass in the idempotent request. And I need to persist this immediately by calling save changes async. So this is my idempotency service. It's pretty straightforward. And I need to also register this with dependency injection. So I'm going to say services add scoped. I'm going to use the generic overload and specify idempotency-service and my idempotency-service implementation. So with this in place, we should be good to go and try out our idempotent API implementation. I'm first going to send the post request for creating a product to the API without including the Idempotency-Key header at all. So if I send this request, I'm going to get back a bad request saying that the required parameter request ID was not provided from a header. The runtime is already protecting me from bad requests. If I head over to the headers tab, here's the header, and I'm going to include it in this request, but I'm going to send an empty value. So we hit our endpoint, but the request ID is empty, and we're going to fail while trying to parse it because we're not going to get back a valid GUID. So the correct approach would be to generate a unique GUID on the client side, include it in this header, and then pass it to our API. If I send this request to the API, we're going to pass the step where we are parsing the request ID, and then we're going to send our command. So because this is an idempotent command, we are going to hit the breakpoint inside of our IdempotentCommand pipeline behavior and land in the handle method. First, we are going to check if a request with this ID exists. So it doesn't exist, and our method returns false. So we're first going to create an idempotent request instance. After this succeeds, we process the command and return back the response. Now I'm going to hit continue. We land back in Postman and our request is successfully processed. Now I'm going to send the same request again, and let's observe what happens. We again hit the breakpoint in the endpoint itself. We're not interested in this as much, so I'm going to hit continue, and we land in our idempotent pipeline behavior. So now the first check, seeing if this request exists, is going to return true, and we're just going to return from our pipeline, and we're not going to be processing the command at all. So if I hit continue, we get back a 200 OK response, simulating that this request was processed successfully, but nothing was changed in the server-side state. Generating and passing in a valid idempotency key is the responsibility of the caller of the API. You don't want to be thinking about this in your backend. You just want to implement support for idempotency and let your client think about generating the idempotency key header. One more thing I want to comment on is in the actual pipeline behavior. What's going to happen if you horizontally scale your API so you have multiple instances running, but the duplicate request lands on a different instance. Assuming you're running multiple databases, one for each API instance, then it's going to be processed one more time. So if you're working in an environment like that, the persistence store for your idempotent requests will have to be the same for all of your API instances. So this is really important to consider. I hope you enjoyed this video about implementing idempotency in an API while leveraging the features that we have, such as MediatR's pipeline behavior. Make sure to smash that like button, and until next time, stay awesome.